Okay, I know when I teach Calc 2, which is on occasion, not too often. My school doesn't have a big demand for Calc 2. Um, what I would do here, I would definitely give a hint on this problem here, and I usually give it as a footnote hint. So I'm going to write down what my footnote hint would say. It would say you're going to multiply the integrand by a unit factor. What's a unit factor? It's 1 over 1. And what I'm going to say is a unit factor I've multiplied with cosecant 2x minus the cotangent of 2x. And if there's a unit factor, the factor of top and the bottom would have to be exactly the same. I would probably leave the hint there, by the way. Say that's it. No more hint. All right? Maybe I give another hint. Use substitution is going to work. All right, so I'll write this over here. So I would say, use the unit factor, and this is the unit factor over here. Sorry about that. This over this is called a unit factor. It's 1. It's conditionally 1, by the way. And then I'd say, use a U substitution, and the U substitution should be this over here. And again, I like giving students hints, by the way. So what do you get? du. That's going to be a tough one, isn't it? Let's see, the derivative of the cosecant. Let's write that down. So I'm just gonna in general, if you can't remember something, you probably could figure it out. So I'm gonna write this down as cosecant of theta is equal to y. And what I want to do is I'm gonna write this as y equals the sine of theta to the minus 1. And so dy, d theta, is going to be minus, it's going to be sine theta to the minus 2 times cosine theta. So it's going to give me, you have to get a negative thing. So you're going to get minus cosine over sine. That's cotangent, right? And then it's going to be, 1 over sine, which is cosecant. Let's write that down. So minus the cotangent of theta. No, not theta, I'm sorry. I'm doing 2x, right? Not doing theta. 2x. I keep doing it. I know that. And then cosecant. 2 theta. And then, I'm sorry, I did it again. And I got theta in my brain for some reason. I think you know why, though. And then I got to put a 2 in front. All right, so I got that part done. I'm going to do cotangent now. And how do I do that? And I'm going to get my little eraser out. I don't need this anymore. I'm going to do the cotangent now. Whoops, went back too far. I did it again. Well, all right, I'm going to do the derivative of cotangent now. So cotangent of theta is the same thing as cosine of theta over the sine of theta. And if I took its derivative, all right, so d theta and d theta, let's see what you get there. Sine squared in the bottom. Sine times minus sine squared. And then minus cosine squared. And what's that going to be giving you? Let's see, the minus cosecant, right? Because, sine squared plus cosine squared is 1. It's minus. So minus cosecant, but minus and minus is plus. And I got a 2 there again. Chain rule. All right, let's look at the k. And we're just kind of studying right at this point. So du, am I getting what I expected to get, which is 2 cosecant squared 2x? I got that there. Minus 2 cotangent 2x cosecant 2x. Things are working as advertised. All right. Now someone says, if I didn't have that hint, I don't think I could have come up with that. All right. Let me get my eraser out. I'm kind of done with all the work at this point, and I verified some things that I couldn't remember. I'll be honest with you, I can't remember a lot of things, by the way. As you get older, you can't remember things, but you could derive those things. You can always figure it out by taking steps. All right. So I want to point out, it's nice to have a hint. All right. And again, we went through the differentiation. We figured that out. And we already talked about that hint they gave you. So you multiply it out, and what do you get? You get cosecant squared minus cosecant 2x, cotangent 2x. And then you're going to use your substitution, right? The bottom is just u, the top is 1 du. All right? I forgot to talk about the 2 then. Let me put that down. Divide both sides by 2, so it's really du over 2. Sorry about that. Can I integrate the 1 over u? I can. It's a natural log. Relatively simple. What do you do now? Write it down, what the u is. A little tricky over here, I want to point out. Do not think you have to deal with these tricks. I am going to go through it, though. This is a really fine answer over here, by the way. But I do want to go through this cosecant 2x minus the cotangent of 2x. I want to go through that with you. It looks tough. What I'm going to do is turn sines to cosines, though. So it's going to be 1 over sine. And this is going to be cosine of 2x over the sine of 2x. All right, let's write this down. So 1 minus cosine 2x, and on bottom you get sine of 2x. Well, the bottom's pretty easy to write down. What's it going to be? 2 sine x times the cosine of x. That's relatively simple. I want to review the cosine of 2x, though. And that could be written down as, well, it could be written as, cosine squared x minus sine squared x. It could be written as, well, let's see. You could take the cosine right in terms of sines and vice versa. Let me put this down. I could write it down as 1 minus 2 sine squared x. All right? So what you do there, cosine's 1 minus sine squared, so it's pretty easy to do that. And then when you get over here, it's going to be 1 minus cosine of 2x. So you're going to get 2 sine squared. Well, isn't that convenient? The 2's cancel. One factor of sine, it conditionally cancels, and then you get cosine of x on the bottom. What's cosine of sine? It's tangent. That's where this second guy. Now, granted, I do think that this one's a better looking answer than what's above it, but you know what? If you get there, it's great you got there. It's even better if you get here, though, by the way. All right? Thank you.